what really happens when you type a website URL into your browser and press enter? It feels instant, almost magical. 1 second you're staring at a blank screen, and the next, a fully designed web page appears. Images, text, videos, everything perfectly arranged. But have you ever stopped to wonder what's actually going on in that tiny slice of time? How does your device know where to go? How does it find the exact server somewhere across the world? And how does all of that happen so quickly that you barely notice? The truth is, what seems like a simple action triggers a remarkably complex chain of events, an intricate dance between machines, protocols, and global infrastructure that unfolds in milliseconds. It all begins the moment you type a URL into your browser. That human-friendly address, like a website name, is not something computers inherently understand. Machines don't communicate in words, they communicate in numbers. So the very first challenge is translation. Your browser needs to figure out the numerical IP address that corresponds to the domain name you entered. But how does it do that? Where does it even start looking? Before reaching out to the wider internet, your browser checks locally. It looks into its own cache to see if it has recently visited the same site. If it finds a stored IP address, it can skip the lookup process entirely. If not, the request moves deeper into your system, checking the operating system's cache, and sometimes even a local network cache. Still nothing? Then the real journey begins. Your request is sent to a DNS resolver, often provided by your internet service provider. This resolver acts like a guide, but even it may not know the answer immediately. So it begins a series of queries across the global DNS system. First, it may contact a root server, which doesn't know the exact address, but knows where to look next. Then it's directed to a top-level domain server, like one responsible for .com or .org. Still not the final destination, but closer. Eventually, the resolver reaches the authoritative DNS server for that specific domain, which finally provides the correct IP address. All of this happens incredibly fast. But pause for a moment. Did you realize that your single request might have involved multiple servers scattered across different continents? And yet, it all feels instantaneous. Once the IP address is found, your browser now knows where to go. But knowing the destination is only part of the story. How does your computer actually establish communication with a remote server? This is where networking protocols come into play. Your device initiates a connection using TCP, a protocol designed to ensure reliable communication. Think of it as a formal handshake between your computer and the server. First, your device sends a request, "Can we talk?" The server responds, "Yes, I'm ready." Then your device acknowledges, "Great, let's begin." Only after this three-step handshake is completed does the real data exchange start. But wait, before any meaningful data is sent, there's another critical step, especially in today's internet. Security. Have you noticed that most websites begin with HTTPs instead of HTTP? That extra S stands for secure, and it represents an entire layer of encryption designed to protect your data. So what happens during this secure connection setup? Your browser and the server perform what's known as an HTTPS handshake. During this process, they agree on encryption methods and exchange cryptographic keys. The server proves its identity using a digital certificate, ensuring that you're actually connecting to the legitimate site and not an imposter. Your browser verifies this certificate against trusted authorities. If everything checks out, a secure encrypted channel is established. Now here's something to think about. Every time you log into a website, enter a password, or make an online purchase, this encryption process is quietly protecting your data. Without it, your information could be intercepted and read by anyone monitoring the network. And yet, most users never even notice it happening. With the secure connection in place, your browser finally sends an HTTP request to the server. This request asks for specific resources, usually the main HTML file of the web page. The server processes this request and sends back a response. But what exactly is being sent? The initial response typically contains HTML, which forms the structure of the web page. However, modern websites are far more than just text. They include style sheets for design, JavaScript for interactivity, images, videos, fonts, and more. Each of these elements may require separate requests. So while it might seem like a single page load, your browser is actually making dozens or even hundreds of requests behind the scenes. Where does all this data come from? Is it always fetched from a single server? Not necessarily. This is where content delivery networks, or CDNs, play a crucial role. Instead of hosting all content in one location, websites often distribute their data across multiple servers around the world. When you request a web page, the CDN directs you to the server closest to your geographic location. This reduces latency and speeds up loading times. Imagine requesting a website hosted in another country. These routers act like traffic controllers, directing packets of data along the most efficient paths. The data itself is broken into small packets, each taking potentially different routes before being reassembled on your device. And what about the physical medium? While we often think of the internet as something abstract, it relies heavily on tangible infrastructure, fiber optic cables laid across oceans and continents. These cables transmit data as pulses of light, enabling incredibly high-speed communication. So when you load a website, your request might literally travel across the ocean through strands of glass thinner than a human hair. Now that the data has arrived, is the process complete? Not quite. Your browser still needs to interpret and display everything. This is where rendering comes in, a sophisticated process that transforms raw code into the visual experience you see. The browser begins by parsing the HTML to build a structure known as the Document Object Model, or DOM. At the same time, it processes CSS to determine how elements should look. Then comes JavaScript, which can modify both structure and style dynamically. All of these components are combined to create the final rendered page. Have you ever noticed how some parts of a web page load before others? That's because rendering is often done progressively. The browser doesn't wait for everything to arrive before showing content. It displays what it can as soon as possible, improving perceived performance. But even this stage involves complexity. The browser must calculate layouts, handle reflows when elements change, and repaint sections of the screen. It also optimizes performance by prioritizing visible content and deferring less critical resources. And all of this, every lookup, handshake, transfer, and rendering step, happens in less than a second. It's easy to take this speed for granted, but when you consider the sheer number of systems involved, it becomes nothing short of extraordinary.
Think about it. A single action from your fingertips triggers a global response. Multiple servers communicate. Encryption protocols secure your data. Routers guide packets across vast distances, and your browser orchestrates everything into a seamless experience. Isn't it remarkable how something so complex feels so simple?
The next time you type a URL and hit enter, take a moment to appreciate what's happening behind the scenes. You're not just opening a web page, you're activating a vast, interconnected system that spans the entire globe. Every click, every request, every page load is part of a coordinated digital symphony. And perhaps the most fascinating part? You don't see any of it. Would you like it?
Hit the like button and subscribe to our channels for more interesting and informative videos.